Welcome to the 6th video lecture for ENSC 2613. Today's lesson will cover nodal analysis. Nodal analysis is a circuit analysis technique predominantly used to find the voltage of one or more nodes in the circuit. It is a three-step process, and the steps are KCL, Ohm's law, and then you solve. In this problem, we're asked to find voltages V1 and V2. The first step is KCL. You assign a current to every branch and write the KCL equations that would be true. We have I1 plus I2 plus I3. The sum of the current out is equal to 0, which is the sum of the currents coming in. And we also have I3, current in, is equal to I4, current out. I1, using Ohm's law, can be defined as V1 minus 100 divided by 25. I2 is V1 minus 0 divided by 50. I3 is V1 minus V2 divided by 25, and I4 is V2 divided by 25. We can plug all of these currents back into our original KCL equations and come up with this series of equations that has two equations and two unknowns, and using some algebra we can solve for V1 to be equal to 50 volts and V2 equals 25. Here's another example, but this time we have a current source in the middle of our problem. You still started out the same way, and we're trying to find Vs, but the step one is KCL. You'll assign a current to every branch and write the KCL that would be true. You have I1 plus I2 plus I3. The current out is equal to 0 because there's no current going in. You have I3 plus 10, current in, equals I4, current out. You use Ohm's law to define these all. You have Vs minus 20 over 10 is I1. You have Vs divided by 10 is I2. I4 is Vs divided by 10 as well. This can all be substituted back into our equations, and we can come up with Vs minus 20 over 10 plus Vs over 10 plus Vs over 10 minus 10 equals 0. And this can be further reduced to say that Vs is equal to 40 volts. Here's a problem where two of your nodes are connected by another voltage source. This makes writing your current equations slightly more difficult, but it's still the same process. You have assign a current to every branch, and on the left side of the 1 volt source we have a node that says that I1 plus I2 plus I3, all of the currents out, equal the current in, which is 0. And then on the right side you have I3 is equal to I4 plus I5, because I3 is the current in and I4 and I5 are the currents out. We can use Ohm's law to define these again. We have Vx minus 40 over 40 for I1, Vx over 10 for I2, Vx plus 1 divided by 20 for I4, and Vx plus 1 divided by 20 for I5. If you're not understanding where these current equations are coming from, please review back to the Ohm's law video. We can substitute these all back into our original equations and come up with this equation. This equation can be further reduced, and you can solve for Vx is equal to 4 volts. You can even use nodal analysis when you have a dependent source. You still have the same process. Step 1 is KCL, so you assign a current to every branch. You then use Ohm's law to define all of your currents. I1 is equal to V1 minus 40 over 10. You have I2, which is V1 divided by 5. I3 is V1 minus 2Vx divided by 10. And right now we have one equation and two unknowns, so we need another equation that can relate V1 and Vx. And using techniques from previous videos, we can say that Vx, the voltage across the 10 ohm resistor, is 40 minus V1. We should now be able to substitute these back in, and after a little algebra you will see that Vx is equal to 20 volts. Here's a bonus problem. I want you to see if you can find Vx, which is the voltage across the middle 10 ohm resistor. We will provide the answer so you can see if you are working this problem correctly. If you are having difficulty obtaining the correct answer to this problem, please feel free to contact the instructor or teaching assistants and we'll be happy to help you. If you're having difficulties understanding where some of the math is coming from, please refer back to the previous lectures. This concludes the 6th video lecture for ENSC 2613. Come back next time and we will cover mesh analysis.